Hey guys, Rail646 here today, and we're in my Minecraft server today, and I'm doing a Minecraft update, and I've been working on a bunch of projects these past few weeks, and I'll show you my first big-ish Minecraft Redstone project today. And this was actually finished about a week and a half ago. We've been working on some more complex stuff that I'll show in future videos, but I'm showing you guys this one today. This is the first one I've done, and it's pretty cool. So what we've got is a basic 7x8 pixel screen, and each pixel is 2x2. And what it does is over here we can turn it on, and what this does is allows us to load an image that I've saved into the memory. So we've got numbers 0 through 9. Let's say I want to load an 8, and as you can see we have a little loading bar with the torches here on the right, and once it reaches the top it'll load the 8 for us. And I'll choose another number just for a demonstration's sake. Let's say we want a 3, so we'll load a 3. Again, you can see the loading bar, and this isn't the fastest screen in the world. It's not, because it was my first Redstone project, my first big one, but it was for proof of concept, and it's pretty cool. And since I've done some more efficient stuff, but it's pretty nice. And you can also load small words on this size screen. I saved the word hi, so I'll show you guys that. And this isn't good for displaying big stuff, but we've made some bigger screens that you'll see in future videos. That are pretty interesting. So apart from just being sort of a screen that can load images, and it won't actually load if this is off, and I'll show you guys how that works in a sec. It also does very basic addition, so it can add two numbers from 0 to 5 together, and it's very basic because it doesn't actually use binary logic, it uses just Minecraft piston logic. And we've made a proper binary calculator over that way that I'll show you guys in the next video, but I'll show you this real quick. So let's say we want to add 1 and 2, so 1 and 2 will obviously give us 3, and this thing's pretty slow. You have to wait about 2-3 seconds after inputting the numbers for it to actually register. Then you can hit this lever here, and we should get a 3 loading eventually. And this was our first project, me and a friend, so it's pretty cool. There we go, 3, and so it's pretty nice. And this button here actually resets the calculator to 0, and yeah, so again, this is just sort of, this here is just linked to the video loading, image loading, sorry, the levers, and each of these is linked to a different lane in the memory, and here is where all of the images are saved. And I can do a video on how this works. It's pretty basic. A torch indicates a 0 or a 1, and that feeds straight into the pixels, into the screen when they're activated. I can do a video on that, just post a comment down below, but it's pretty basic. And up here we have the really basic adder, and again this is not binary logic, this is using piston logic, and you can probably figure out how this works. It's just a loop of pistons that carries this solid block around, and whenever this block goes over here it delivers power to this master loop, and this is where the addition actually takes place. So you see right now it's set to 0, and if you inputted say a 1 here, this would spin around once, which would input this signal once to the master clock, adding 1. Then here, let's say you inputted a 3, this block would go around 3 times, and it would add 3 to the total here, and this links directly to the appropriate number. So pretty basic stuff, and this may look a bit confusing if you haven't done much Redstone, but leave a comment below and I can make a video on how this works, and you'll be astounded how quickly you can figure it out. And it's pretty nifty because it doesn't use any complicated binary or logic gates, but it's a bit limited by that, especially by the piston block push length. But it's pretty cool, and our busing here isn't very efficient either, so but it is our first project, but it's pretty nice. So pretty cool little proof of concept. And the other thing I wanted to show you guys in this video was here. This is a 3x3 pixel screen, so there's 9 pixels total, and same thing, this has a bit more functionality than the one over there in terms of image saving and loading, because this one does not only have ROM, and ROM is essentially the memory where the images are saved over there, so you have to manually place the torches in regards to which pixels you want to activate. But here, so we have that, but we also have RAM read, so we can actually save an image from this interface and then load it. So first of all, ROM read, so that's the same kind of memory as over there, and I saved, there's 2 different images you can load, and one of them I believe is all the outer pixels, yes, and the other is just the middle pixel, so just contrasting there. But then let's say we want to save an image to RAM, right? So we can't modify the ROM images because they're saved right here. So these are the images saved in ROM. You have to manually place a torch for it to save. It won't actually, you can't actually change the image, you can't change the data from the interface. But then if we go to RAM, and let's say, well, here you can see the X defines which pixel will be illuminated. So here, top left, top middle, top right, middle left. So let's say I want to save, we'll do all the top row and all the bottom row. Oops. And we'll save that to the first register, or the register 0, or just the first slot we can save to. And there's 2 different slots we can save an image to. And so we've saved that. We've actually saved that to RAM. So there is now an image in RAM being stored that will display the top line and the bottom line of pixels. And now we can, since we can save 2 images, just for proof of concept, I'll save the second image as having the whole middle row activated. So we'll save that to the second one, or register 1, because in computing we always start at 0 and then go to 1. And this isn't heavily complex either. I'll probably be making some tutorial videos where I explain this, and once you get your head around it, it's pretty easy. And so you see now we're still on ROM read, right? So if we try read any of these images, it'll still give us the images we saved into the ROM over there manually. But if we switch to RAM read, or if we actually read the images we saved in the RAM, whoops, there we go. Now we can load this one, which was the bottom and the top pixels. Whoops, that's a bit of a glitch there. I'll just try resave. Which one did I miss out? Bottom left. So apparently this one didn't save. I'll have to resave the whole image. Sorry about that. Must have missed it for some reason. Here we save. And now we will remove all the inputs and try reload the image. So it should give us bottom and top. Huh. That's quite strange. For some reason that isn't registering. I'll address that in a sec and get back to you. Hey guys, I found the bug. It was really silly. I was just missing a little bit of redstone here, so the signal wasn't actually getting through. So if I put that bit of redstone there, we should have the image we saved. Sweet. So I don't know what happened there. Maybe a friend of mine was tinkering with it, but so that's pretty cool. And the image we saved into register 1, or just the second slot, was the middle row. So there we go. That's pretty cool. And I'll save a different image just to show you guys. So if you remember, I'll just keep this activated. This one has top and bottom, and let's say I want to switch that to, we'll make an X, a sort of an X here. So we'll do that one, that one, that one, and that one. And then we'll save that to the register we're currently reading. So I'll just turn it off for a second, and then save it up top. And now if we read again, we should get the image we just saved, which was an X. There we go. So it's pretty cool. And you can alternate between reading from the RAM and the ROM. And you can see the RAM is a lot more useful. You can do a lot more with it than the ROM. But it's not as practical. Not nearly as practical wiring-wise, sorry, if you just got a basic screen that you want to make. Because here is all you need, really, to load an image from ROM. And this is RAM. You need to interface all of it. And if you want to have each individual pixel activatable, it's not really nearly as practical as ROM. And here we have 2 9-bit registers of RAM, and 9 bits because there is 9 pixels, thus 9 1 or zeros, and 1 will give us an activated pixel and 0 will not. So there we go. I hope you guys enjoyed. It's just 2 little redstone things, and these were completed a little while ago, about 2 weeks. And that project over there is actually what I've been up to. And there's also one further out that way, a huge screen that I'll show you guys. But so yeah, hope you guys enjoyed, and stay tuned for some more videos. And I'll be sure to have some more redstone stuff coming up, some F1 and some Minecraft. So look out for that, and I hope you enjoyed. And I'll see you later.